Let's take a look at the solutions to the questions behind me, starting with this one where we are considering ourselves on a Ferris wheel with radius 30 meters, rotating 3 times a minute. We want to find our linear speed and our angular speed. We need to recall definitions for linear and angular speed. Why don't we write those up first? We can recall that our angular speed is equal to the angle we traverse over time, and our linear speed is given to us by the distance we travel over time. Furthermore, we can note that the linear speed, or the distance we travel over time, is given to us by the radius times the angle which we traverse over time, which is also a relation that we can find between the linear and angular speeds, that the product of the radius and the angular speed is the velocity. So what we'll do to solve this problem is we'll first find the angular speed, and then we'll use that to find the linear speed. So how will we find our angular speed? Well, consider this piece of information that tells us we rotate 3 times a minute. Well, that means that we could traverse, say, 3 times 2 pi radians in 1 minute. So when we look at our angular speed here, we can say our angular speed is equal to 6 pi radians traversed every 1 minute. We find our angular speed, 6 pi radians per minute. To find our linear speed, I will choose to multiply just this by our radius. No, our radius is 30 meters. We can say our linear speed is equal to 6 pi times 30, which is 180 pi. And note my units here. I have radians per minute and 30 meters. Note that radians are unitless. I can just treat them as a number. So I have meters per minute as my unit. Give that a box and call that problem done. Let's go ahead and look at the second problem we want to work with, where we consider a wind turbine with diameter of 56 meters, and a point at the end of the turbine has a linear speed of 10.2 meters per second. Find the angular speed of the turbine in degrees per second. So how will we do this? Well, note we are given an angular speed, or maybe we can even draw a diagram to help us figure out exactly what's happening here. So we have like a wind turbine, and we know a couple things about this turbine. We know that it has a diameter of 56 meters. We know that a point at the end of one of the turbines, or one of these blades, has a linear speed of 10.2 meters per second. So what can we do to solve this problem? Well, we could note that we're trying to find an angular speed, and we can note a relation that we've already noted, that the angular speed is, that the linear speed is a product of angular speed and radius. So how could we rearrange that relation? We can note then that the angular speed is just the ratio of the linear speed and the radius. We could also note that from our diagram here, if our diameter is 56 meters, our radius must be 28 meters. So we could look at the ratio of our linear speed, 10.2. This would be in meters per second. We're dividing that by our radius, 28 meters. But note that this would give us some unit that was radians per second, or a uniless count, because our meters and meters would cancel. We just have a seconds in the denominator. And we wanted to find our angular speed in degrees per second. So we also need to multiply this by a conversion factor to convert radians to degrees. And we also want, so what will we do there? Well, we know then to convert a radian to a degree, we multiply by 180 degrees over pi, and then we'll have some measure in degrees, not radians, as we're looking for. Now, if we approximate this value, it turns out it's about 10.436, and that would be in degrees per second.